Oh my God.
All right, guys, girls.
Don't put out the tea.
Don't what? You where?
Wait, so you just want me to fill it up with water?
Yeah.
Not dump it.
Don't dump
No
it.
dumping.
Oh my God,
Just fill
am
it
I
up
like
with
the servant here?
Yes.
What is this?
Live action. All right. So I know some of you might have done the even. Some of you might have done the odds. Let's run through, see how we did. Clear ink. Problem number 1. I have this. Can I add those together? Are they like terms?
Yes.
They are. What number is sitting right here?
2.
There's a 1 right there, so this answer is 4 root 5. Done. Okay, second problem is this. Are these like terms?
Yes.
Yes. I'm just going to subtract, so I get a negative 5 root 3. All right? Problem number 3. Are these like terms?
No.
Could they be maybe?
Maybe.
What would stick out maybe a little bit that they could be like terms? Yeah, I could work them out a little bit. So I could break 20 down to 4 times 5. And the reason I'm choosing 4 times 5 and not 2 times 10 is because 4 is our largest perfect square. So this is the same thing as 4 and then 4 times 5. And then this is the same thing. What's 45 the same as? 9 times 5. The reason I'm not choosing 3 and 15 is because 9 is our largest perfect square. So what's the square root of 4? 2. That 2 comes outside. What happens with these two then? They multiply, so I get 8 root 5. Plus, what's the square root of this? 3. That comes out. What happens here? Multiply, so I get 6 root 5. Are they like terms now?
Yes.
Why?
Because they have the
Same what?
same radical.
Same radical. So now I can add them together, so I'm going to get 14 root 5. Done. That seem okay so far? So it's possible you have like terms, but you don't recognize it because you have to break down the problem a little bit. Problem number 4, we have 3 root 18 plus 7 root 50. They do not appear to be like terms yet, but I think I could break 18 down to what times what? 2 times 9. 6 times 3 is also correct, but we're looking for the largest perfect square. And then 50 is the same thing as what times what? 25 times 2. And the reason I'm not doing 5 and 10 is because I'm looking for the largest perfect square, and which 25 is perfect square. What is the square root of 9? 3. What happens with these two? They multiply. Plus, what's the square root of this? 5. Multiply those. Are they like terms?
Yes.
Same radicals? Absolutely. Add them together. 44 root 2. Seem okay so far? Can I clear these? All right. 2 root 36 plus 3 root 12. Let's take a second, try and work it out a little bit. How are you going to work this out? Do what? What do you got? Okay. Can I break 36 down, or is it a perfect square as it sits? It is a perfect square. What is the square root of 36? 6. And what 6 does what to the 2? Multiply. So this gives me 6, so this gives me 12 for an answer right now. Are we okay so far? Can I break 12 down? Is it a perfect square? It's not a perfect square. It does have a perfect square that's part of it. I have this. So what's the square root of this? 2. What does that do to this? Multiply. Are these like terms like they said? No. That's my answer. It's simplified. It doesn't get any better than that. Number 6. I have 5 square root 80 minus 4 square root 24. Okay. Let's see. 80 is 2 times 40, but that doesn't really help me out. 80 is 4 times 20. That doesn't, 4 is a good perfect square, but maybe not. What times what gives me 80? Largest perfect square. How do we go through that? I mean, I can do this. I can say, Let's break 80 down. Bless you. That's 2 and 40. That's 2 and 20. That's 2 and 10. That's 2 and 5. What would determine a perfect square up there? How many of a kinds? 2 of a kind. Oops. Does this give me a perfect square? What about this one? So that would be 2 times 2 times 2 times 2. That's 16. 16 times 5. And then if I break 24 down, oh, that should be a subtraction sign, sorry. And that's going to be 4 times 6. So what's the square root of 16? 4. What does that 4 do with this 5? Multiply. Minus. Square root of this? 2. Multiply to this. Is root 5 and root 6 the same? No. That's my exact answer. I know what I was going to tell you guys yesterday. We got off task a little bit, believe it or not, here. Exact answers are what you would want when you're dealing with, like when we talk about going to Mars. You want exactly to know how far away it is for those computations. You want to know what different angles would be for perfect computations. And the reason is, when you're in a rocket ship, you basically launch your thrusters, you make a few orbits that are exiting orbits of the planet Earth. It's usually 3 or 4, maybe even 5 times, and then you slingshot away. You build up enough speed that the gravitational pull of the Earth is not great enough against your vehicle or your spaceship that you're then able to launch or go into a different direction. The more exact of an answer you have, the less you would have to do to try and correct your course later, because you only have a certain amount of fuel on board or air jets on board to manipulate your vehicle to compensate for not having something exact. So if you were to have like a decimal answer, and it's a long decimal, it doesn't repeat, that could be an error that could mean that you miss Mars, you skip off the atmosphere because you're coming at a wrong angle, you slam into it, or you get exactly there. Pretty sure getting exactly there would be the biggest motivation you would want if that was your true journey. Okay? So I just kind of give you a heads up where an exact answer would help you out a lot. Then we get to a problem that looks like this. How many 3 root 7s are being multiplied together? 2 of them. Okay? So some people might see, oh, I'm going to distribute this in, but you have to see the math that's taking place. These mean the exact same thing. Okay? If I'm multiplying radicals, and I'm multiplying numbers, outside, outside, that's 3, that gives me 9. What does that give me? No. 7 times 7. 49. Square root of 49 is 7. So the answer to this is 63. So now we can get rid of a radical sometimes. But number 8 is done very similar. I have 10 root 2 quantity squared. What do you think I get? Radical 4. Okay, so you have this twice. Being multiplied, right? 10 times 10 is 100. Root 2 times root 2 is root 4. Root 4 is... So you can multiply radicals together. Pretty interesting. And if they multiply the exact same thing, it becomes a perfect square, and then you can take the square root of it. So the square root sign undoes the perfect square. Number 9, we have root 2, and then root 6 minus root 10. I'm going to distribute here and here. What is root 2 times root 6? Root 12. Minus, what is root 2 times root 10? Does 12 have a perfect square part of it? So you're saying that's 2 times 6, but what else is it? 4 times 3. What about 20? 20 is 2 times 10, but what else is it? 4 times 5. Square root of 4 is 2, so I get 2 square root of 3 here, minus square root of 4 is 2, so I get 2 root 5. Do I have like terms? Here's my answer. What's crazy about it? It's okay, it's crazy. It can be crazy. Got it clear? Clear in ink. All right. All right. We're going to start over here. We're going to zigzag through the rest of the problems. Next step, Preston. What should I do? What's the D word in math? Distribute. I like that one. Divide is right too. That's the D word math. All right, so I'll distribute. So can I go 4 times root 3, and what do you think I get if I go 4 times root 3? No, I like what you're thinking, but I don't have both of them being under a radical. So if this was an x, I went x times 4, what would I get? No, 4x, right? So what is this going to be? 4 root 3. All right. Christian, if I go this times this, can I multiply inside the radical to inside the radical? Okay. What is 3 times 3 then? 9. So I get 2 root 9. Okay. Coming over here, going and back. What's root 9? 3. So this is staying as is. That becomes a 3. So I get this. Angelo, is that answer done? 4 root 3 minus 6? I will tell you that sometimes it's preferred to have it like this. And what did I just do? What's the difference, or what's the same, or what? What do we know? What do you got?
You took the minus 6 to the left side.
So the reason why that's sometimes done is sometimes people draw the radical sign too far and it looks like 3 minus 6 under the radical. So I'll accept either way. Just be careful how far excuse me, how far your radical goes. Number 11. Casey, what's the big word in math that we use? Giddy up. It's distribute, not giddy up. But no. All right, so if I multiply here and here, what's being multiplied on that very first part? What do you guys think? And girls think? What? Root 6? You want to someone verify that? Wait, root 6?
Wait, no.
Root what?
Root 2, 15.
Root 15. What? 10? Wait a minute. Hang on. What's 3 being multiplied by? Well, not nothing. There's a 1 really right here, isn't there? And then where did the root 10 come from? Yeah, I multiplied the radicals together. So I can multiply inside to inside. I can't go outside to inside, though. All right, let's try this next one. What is that times that? 9? Root what? 25. Okay. Can I break 10 down into any perfect squares? It's 2 times 5. It's not going to break down. So 3 root 10 is pretty content how it is. Uh-oh. I'm slowing down again. Plus square root of 25? 5. And what's that going to do to this 9? Okay? And again, sometimes it's preferred to write it like this. I think both answers are 100% correct, but just watch out because again, a lot of people will draw the radical sign saying, "Oh, it's going over everything," and so they've just changed the order to make it a little better for us all. I think they'll kind of get these. Uh-oh. Number 12. Four-letter F word in math.
4.
4. I like it. It's another one. 5. Good. No, that's more than 4 letters. What about foil?
Isn't that usually used?
The aluminum version, yes. All right, foil. It's an acronym for first. So 1 times 1 is 1. Outside. 1 times negative root 3. Negative root 3. Inside, the I. 1 times root 3. Root 3. Last.
Oh, root 9.
Root 9. Good. Let's see. These are opposite terms. Do you agree? So they cancel each other out? What's this? So I get 1 minus 3. Answer is? 2. There's no radicals there. So foiling sometimes will work. Last. Yeah, so the first terms, the outside terms, the inside terms, and then the last terms. Some people call it the lobster claw. That's the lobster claw method. What? Looks like a lot. I mean, of course, we live, 1,000 miles from any given ocean, so we never know what sea life looks like. Until you get somebody to say, yeah, they got fresh sushi. There you go. Crawdad method. Let's go. Yeah, it's kind of an oxymoron, right? Fresh sushi. I mean, sushi is raw fish, so I hope it's fresh. I do too. And then you get it. No, they fly it in every day.
So sushi.
Really? They caught it probably yesterday, put it on an airplane. Maybe.
Maybe, if we're lucky.
Yeah, they got all kinds of good stuff. Where should I even approach this problem? So, what do you mean find out the numbers? I think we might be on the right page. What are we doing?
I was going to say you find out what 3 numbers are in the void or something. I don't know.
Okay, no, I think you're right on. I like that. So you're on the right page. So I'm going to do this. 2 times what is 40? 20. 2 times what is 20? 10. 2 times what is 10? Can I break that down any further?
Yeah.
So 2 times 2 times 2 is 8 times 5 is 40. How many of a kind am I looking for? 3 of a kind. 3 of a kind because I'm looking for third root. So that comes out. So I get 2, and then I have third root of 5 right next to it. Done. So that was threw a little trickaroo on you. I wanted 3 of a kinds. Now we're back to 2 of a kinds. What do you think? I'm looking for 2 of a kinds. Ideas? Yeah.
98 can go into 49 times 2.
Ooh, 98 and 49. Why are you choosing 49? I like it.
Because it's half
It's half of 98. Is there anything special about 49 right now? It is a perfect square. So we found a perfect square. If 49 wasn't a perfect square, I'd keep breaking it down, see if we can find some pairs of stuff. And then I have okay. What is that? 7. What it gives me with that? X squared. And that's all outside. What's left inside? 2x. Done. Interesting. Well, not really. Just a math dude. Almost done with this page. Clear? Here's my dude. I get the kid back. Mud isn't clear though. So this is the same thing as this. Yes or no?
Wait, what's the same thing?
Are they the same?
Yes.
Absolutely. What's the square root of 16? What's the square root of y to the 4th? Y squared, good. So on top I get 16y squared. What's the square root of 49? Square root of x squared. No, just x, right? So I'm looking for pairs. I cannot reduce 16 over 7. I don't have any tug of war because I have different letters. That answer's done. Okay. How did I do it? What's the math? I multiply. So can I multiply here and here? Both outside, what do I get?
8.
Okay, and then I have a radical. What happens if I multiply here and here? 18, okay. What about here and here? Here and here. Okay. So I think I can break this down a little bit further. 18 is the same thing as what times what? 9 times 2, and then x squared, y squared. What's the square root of 9? 3. 3 times 8 is? 24. Square root of x squared? Square root of y squared? What's under the radical? Done. I get it, I think. Ooh, find a mistake has been made in each. Find the mistake and correct the problem. So they have square root of 50 is the same thing as this times this. And then they say this is the answer. Do we see a mistake? It might be right. I don't know. Yeah. They can be. This can definitely happen. The rule that's going on right here is if I add x times y, that's the same thing as square root of x times the square root of y. Definitely. So that's the same idea where I'm using x and y to represent numbers.
Well, I mean, the answer doesn't look quite right, but I don't know how they got it.
Okay. So let's ask ourselves, are we okay from this step to that step?
Yeah, I know.
What do you got?
So they put 5 instead of in the radical instead of the 2.
Ooh. Yeah, what's square root of 25?
5.
So the mistake is I should have 5 square root 2, and they had flip-flopped that. They had flip-flopped that. So a little trick there. And then problem number 21, let's see, 21 we have this. Can I clear this? You know what? I want to try and do it our way. Let's, because they have it all worked out, but I think they have it incorrect. So let's see if we can figure this out. Okay, so I'm writing it all the way out. Is there a number up there that's a perfect square? It's the 4, right? Square to that is what? 2. What happens to that in this? That becomes 8. Still with me? Looking for pairs. What comes out? What comes out? Y to the 4th. Does that make sense?
Yeah.
What I have it left inside? 6xy. Okay, let's take a look at their answer. Oh. Ah, look at that. They didn't remove enough y's. That's what they did. They didn't remove enough y's. They went y to the 3rd, and we still had one sitting in there. Yeah. Oh, that's a little error. Okay, so we're okay. All right, today, what I want us to work on, it's a review. You have the rest of the period to work on pages 50 and 51, which is worksheet number 24A. So I'm going to walk around and help you out on this. So I'd like you to work on it, and we will go over it next time. But I am not giving you the rest of the period to do nothing. I want you to work on it, okay?